we are going to discuss about the second year physics important 8 marks question, nuclear reactor and its working principle. Now, nuclear reactor. What is the meaning of a nuclear reactor? The arrangement in which the nuclear fission is take place by itself sustained in chain reaction is called nuclear reactor. Okay. Now that means the chain reaction which is take place self-sustained. Now here, what is happening in the chain reaction means one uranium is bombarded with the one thermal neutron and it releases 3 prompt neutrons and it is splitting into the barium and krypton. Now this reaction is continuously going on. Okay, that is considered as a chain reaction. Now what is the principle? Simply we are saying that it is working on the principle of controlled chain reaction. Okay, if it is not controlled, then it becomes atom bomb. Now, what are the main parts of the nuclear reactor? Now, this is the block diagram of a nuclear reactor. Now, this is considered as the core of the nuclear reactor. In this one, we are placing the fuel, okay, next moderator and control rods, and we are having some shielding protection. From this one, we are having connection with the some pipes, coolant to the water at high pressure. We are sending this one. Now, it is converting into the steam here. Now, what are the main parts we are taking here? Nuclear fuel, second one, moderator, next third one, control rods, fourth one, shielding protection, fifth one, coolant. Now here, what is take place here? Means fuel is filled in the aluminium cylinders which is having the fine holes. Okay. Next, it is placed in the center of the core. And at the adjacent sides, we are taking the moderators. One thermal neutron is inserted in the aluminium cylinders. Now, the fission reaction is take place. Okay, now continuously it is going on. Okay, now 3 prompt neutrons are released. Now, here, nuclear fuel. The fissionable material is called nuclear fuel. What we are taking as a nuclear fuel means uranium, U-235 and 238. Okay. In some way, we are taking the plutonium, thorium also. Next, now reaction is take place, prompt neutrons are released. Now, which are not participating in the chain reaction. So, why it is not not take place in the nuclear reaction means it is having high energy, about 2.5 million electron volts. To reduce this energy up to 0.025 million electron volts, okay, we are passing through these neutrons through the moderator. Moderator is one material which can slow down the fast moving neutrons. Now, the material which slow down the velocity of the neutrons and allow them to participate in the fissionable process are called moderator. Example for moderator is heavy water and graphite and beryllium. Next, the reaction is going on. Then we have to control this reaction. We are using the control rods at this point. Now we can inject into this one. Now we can drag this one. When we are injecting into this one, then what happening? It can absorb the neutrons. Then reaction rate is decreased. Now, control rods. The rods which absorb the neutrons, control the chain reaction are called control rods. Now, what we are using here? We are using the cadmium and boron as the control rods. When the reaction is take place, okay, the high energy is releasing and it releases some alpha beta particles also. Okay, then what happening? Next, gamma rays radiation also. Now we are considering the shielding here. To protect this person who is operating this nuclear reactor and surrounding environment, we are constructing one wall that is called shielding. A steel and lead concrete walls of the thickness 10 meter are constructed around the nuclear reactor, which shielding to decrease the intensity of the radiation of beta and gamma rays and protect the person working near the fission reactor. Okay, right. Now that means if any explosion is take place in the nuclear reactor, we have to protect that environment. So we are we are taking the shielding. Next, here energy is released. Okay, now that energy we have to observe and utilize. That is why we are using the coolant. Coolants absorb the heat generated in the reactor. Generally, which are the absorbing the heat means water, at high pressure and liquid sodium. Liquid sodium is we are taking. Next, now this is the process of working. Okay. Now with respect to this one, okay, the heat is generated. The heat is moved toward turbines. The turbines are connected to the dynamo. When the dynamo is rotated, now electricity is produced. Now this is the process of nuclear reactor to produce the electricity. In the same way, we can prepare some radioisotopes also. We can prepare some radioisotopes also. Next, we have one problem. Okay, 1 microgram of uranium is completely destroyed. How much energy is released? How much energy is released? Now, what is the given here? 1 microgram. 1 microgram. That is equal to 1 microgram is 10 to the power of minus 6 grams. That is equal to 1 gram is equal to 10 to the power of minus 3 kilograms. Now combinedly we are writing, okay, 1 into 10 to the power of minus 9 kilograms. Now how much energy is released? E is equal to how much? From Einstein, mass energy equals theorem, E is equal to what we are writing? mc square. E is equal to mc square. Now here m is mass. Next c is the velocity of light. It is given c is equal to 3 into 10 to the power of 8 meter per second. It is given or not given, you have to remember this one. Now m is 1 into 10 to the power of minus 9 into c 3 into 10 to the power of 8 whole square. Now 1 into 10 to the power of minus 9 into 3 square is 9. 10 to the power of 8 square is 10 to the power of 16. Now it is 10, 9 and this 16 get cancelled. Now we get 10 to the power of 7. Now here 9 is there. 9 into 1, 9 into 10 to the power of 7. 10 to the power of 7 joule. Followed? Now this is the problem. Okay, now this become total 6 marks. Now problem become 2 marks. Total 8 marks. It is important question. Okay, question for the IPE examination. Thank you.